Okay, what I want to do here is review for our final. What we're going to do here is a lot of the stuff from the third quarter. It's been a while since we've done that, so what I want to do with this is I'm going to do some of the more challenging problems from these sections. If you know how to do these challenging problems, you're going to know how to do a lot of the simpler problems, which are going to be steps within this problem. So the first thing I want to look at is an empirical molecular formula problem here, and they give us mass percentages, which is going to allow us to find our empirical formula, and they give us the molar mass, which is going to allow us to find our molecular formula once we have our empirical formula. And so again, the mass percent is only enough to tell us our empirical formula, which is just the ratio of moles, because if you have something like C2 or CH4, it's going to have the same mass percentages as C2H8. It's just the ratios there, so it's not enough. But what we can do, so if we know the mass percentages here, again, we're interested in the ratio of molecules, so it doesn't matter what total sample size we have. So it's easiest just to keep it as, say we had a 100-gram sample of this. These would be, the percentages would be how many grams of each element we had. So we'd have 42.87 grams of carbon. Okay, we'd have 3.598 grams of hydrogen, 28.55 grams of nitrogen, of oxygen, excuse me, that's oxygen, and 25 grams of nitrogen. Okay, and so if we're talking about the ratio of molecules, we need to know the ratio of moles. So all these things that are in grams, we need to convert to moles, in which we're going to do that with our molar mass. Okay, and so this gives us about 3.57 moles of carbon. And about 3.57 moles of hydrogen. We're going to have 1.78 moles of oxygen, and we're going to have about 1.78 moles of nitrogen. Okay, and so once we have these, amount of moles that we have in the 100-gram sample, what we care about is the ratios. And the ratios here, you can kind of tell just by looking at it here, is going to be about 2 to 2 to 1 to 1. But if it's not as obvious, what you need to do is divide everything by the smallest number of moles, which in this case is 1.78. So if we divide all those by 1.78, we do get our 2 to 2 to 1 to 1. So if that comes out, these are like 2.005, which is close enough to round. If it's something like 2.5, that's not going to be close enough to round, and what you need to do is multiply all of these integers by a factor to get them to the lowest, so that they're all the lowest integers possible. Okay, and so by doing that, our empirical formula is C2H2ON. Okay, and so that's our start. Whatever our actual formula is, it's going to be some multiple of these ratios here, but we don't know what it is yet. And so to do that, we want to take a look at our molar mass. Okay, so we'll compare our molar mass to what the molar mass of this would be, and we can get our ratio here. So our molar mass of C2H2ON is about 56.046. And so we compare that to our molar mass, and so they give us a range. I just like to pick something in the middle, so we need to compare 167.5 grams per mole to 56.046, and if we do that, that's 2.988, which is really 3. So our actual formula is going to be, with the same ratios here, but 3 times bigger. So that means we multiply all the subscripts here by 3, so our molecular formula is going to be C6H6O3 and 3. Okay, so this is our empirical, this is our molecular,